So thank you everybody for attending this conference talk on Localhost XCUITest. So my name is Kenneth Poon, and here's my profile. I'm a principal software engineer at SP Digital, and SP Digital is the digital arm of SP Group, which runs and manages the transmission of energy for the Republic of Singapore. I like to bring agile development into the iOS space, and in Singapore, I'm a regular Tech Talk contributor to the iOS Dev Scout meetup group. Here are some of my popular talks that I've contributed to the community, mainly about testing and how to hack iOS apps. So back in 2017, I was here in Bangkok giving a talk on dynamic library code injection and showcasing how you can write Swift code to hack the iOS Pokemon Go. So you're interested to know more about the hacking, just find me during the break. So I'm very honored to be here speaking today at Mobile Conf. And the topic I'll be focusing on today is on testing, in particular, XCUITest. So now, show of hands, how many people use XCUITest at work? Wow, so few. So I know most of the people here, you guys do use unit tests, right? But many people don't really use XCUITest at work. So my goal for today, for this talk, is to change the way you look at this feature, and I'll show you how you can easily write effective and accurate XCUITest. So XCUITest was launched in 2015, and it was available as a test target in Xcode. Since then, it was an amazing milestone because UITest can now be written with native iOS languages, Swift, Objective-C. And since then, XCUITest has become Apple's recommended iOS UI automation tool. And it's not difficult to write an XCUITest case. So all we need to do is start off by creating a Swift file and set up the following code. Import XCTest, create your test class, your test function, and then we create an instance of XCUI application, and then we add interaction code that simulates the user behavior on the app. And lastly, we write our assert statements to verify our expectations. So it is that easy. With this setup, we can easily create end-to-end XCUITest, and you can run them in test or even production environment. But running end-to-end test has its issues. Firstly, there are lots of dependencies, such as the API server, database instances, third-party mobile services, and all are needed to be properly set up before we run the test. And because of all these dependencies, it makes writing tests more difficult. And because we are running our end-to-end tests that hit shared services, this might lead to concurrency and even repeatability issues. So even if we can write our XCUITest, we may not be able to achieve comprehensive UI automation test coverage. Now let's look at iOS testing using the test pyramid. At the top of the pyramid, we have end-to-end test. At the middle layer, integration test. And at the bottom, we have unit test. For most iOS development setup, engineers will use XCTest for unit test, and XCUITest or even APM test for the end-to-end test. But we know writing end-to-end test won't be able to provide us with good test coverage. And here I like to recommend two categories of integration test: the mobile contract test and the mock response test. So the general setup for a mobile app is the app and its interaction with a server. In mobile contract test, we will mock the app and test the API integrations against the server. One example, we can run a series of curl commands that simulate a use case and assert that the server is working as expected. So this kind of test usually checks the schema and sometimes the data or the response. If the mobile contract test fails, there's no point running our end-to-end test because failure in the mobile contract test has proven the point that something in the back-end system is not running properly. In mock response tests, we are going to flip it around. We will mock the server and assert how the app behaves. So for iOS, one way to set up mock response test is to use Localhost, where we basically create a web server in the test runner. And mock response test will be the focus of my talk today at Mobile Conf 2019. And I'll share how we can marry XCUITest and Localhost together. So now I'll show you how easy it is to create Localhost test. You just need to remember these 4 basic steps. L, A, I, and M. L, A, I, M. And L stands for localhost. We need to set up an in-memory localhost server. A stands for API. We need to redirect the API to hit our localhost server. And I stands for Info.plist. We need to patch, do some updates to our Info.plist. And M stands for mock. We need to set up our mock responses. So the steps are L, A, I, M. So the first letter of the steps is L, that's localhost. So here, we need to set up an in-memory server in-memory server in the test runner. And we have to assign a unique port number to it. And we will set up and tear down the localhost server when we execute each test. So this is an example of how to set up localhost in your codes. Firstly, we import XCUITest and we create our test class. And then we import Swift localhost. So this is a CocoaPod library which I've written, and it helps to encapsulate the complication of creating a localhost server. And then next, we create an instance of localhost server. In the setup, we will initialize the server with a random port number. And then we will tell the server to start listening. In the teardown, we will tell the server to stop listening. But however, using a fixed port number may not be ideal as it prevents us from running our test in parallel. So instead, we're going to use this class function, initiate using random port number, to assign the next available port number for use. So after L, the next letter in our steps is the letter A. And A stands for API. Here, we are going to redirect our existing outgoing API calls to hit our localhost server. So assuming that you have a class, a network operations or manager class, where you have a variable that holds the API request path, instead of hitting that path, we're going to hit localhost server assigned with the port number. So LA, the next letter is the letter I, and I stands for Info.plist. Because we are using an HTTP localhost server, we will need to patch our Info.plist file to allow for local HTTP request. Under App Transport Security Settings, for iOS 10 and above, we simply add NS allow local networking. And if you're still on iOS 9, you will need to add localhost as an exception domain item. And after I is the letter M, and M stands for mock. Here we are going to set up our mock responses based on the API being used in the test case. So this is an example how mock response setup may look like. In our test function where we have our test codes, using localhost server, we will call the route function and specify that whenever it receives a GET request of path 3 movie popular, we are going to return the contents of the JSON file home popular. And that's it. We are all ready to use the steps LAIM to set up our very own localhost based test. But wait, we can go further. So one of the interesting features of using localhost is that we can assert outgoing API requests. So let's assume we want to describe a use case for bookmarking an item on a shopping app. So in our hypothetical use case, we'll start off on a listing view. Here the app fires a request to fetch items to load on a table view. When the user selects a row, the app will navigate to the details page. Upon screen load, the app fires another request to fetch the detailed information on the selected item. And on this screen, the user can tap on the bookmark icon to like the item. And the app fires another request to bookmark the item. So in this use case, we expect 3 requests to be fired from the app and to be received by the localhost server. And we can use Swift localhost library to write tests to make sure that these requests are being fired in this particular order, no more, no less. So this is a snippet of the localhost server definition. It has a public variable recorded request that records the URL request that's been fired from the app. In our test, we will inspect this variable to set up our assertion statements. We can specify and assert the order of request by the URL path used in our test. Here we have an expected string array of first item path 3 movie popular, and then of path verify password, and the last one of path get account info. And we can inspect the actual recorded request paths, and then assert that both expected and actual request paths are the same. We can also represent the request as curl commands in the string format in this way. So take note, for the second and third item, we are also asserting the HTTP body contents in the request. We can then create expected curl strings and assert that the actual curl strings matches what was expected. So now let's take a look at some codes. So instead of writing my own app, I search GitHub for a project that doesn't have any test, so that I can show you, all of you, how easy it is for any developer to write Swift localhost test on your projects. So special thanks to this person by the name of Mohammed, and this for giving me permission to use his GitHub repository. So the first link is the original GitHub by Mohammed, and the second one is the forked repository, where I implement Swift localhost. Okay, let's go. Okay. Oh, let me get some internet first. Okay. Cool. So let me show you what this app is about. I think I can. Is it better now? Okay. So let me show you what this app is about. So this is basically a movies app, and here we have a collection view, and each collection view cell is represented by a movie poster. And clicking on the poster, we will get the movie details. And then we have some buttons here where it shows, clicking on them shows the popular upcoming movies, top rated, and movies now playing in the cinema. So on this project, I added an additional feature, which is, sorry. additional feature, which is file-based authentication. So tapping on this button, I will show the login page. And let me register a user. So I type happy developer1@gmail.com. Password, I put password 1. Let me clear the console. And I register. Hello. Okay. So I registered the user. So let me go to the console. I search for happy developer, and here I have the curl request here. So this is the actual curl request that's been fired from the app to file-based authentication. I can copy this, and go to my Postman, import the command. Let me close this, and then I send. And I get a request 400 because I've already created the user on the app. So find the request again will fail. So I go to body, I change from developer 1 to developer 2. And then when I send, now I get a success response. And this is the JSON response of what Firebase is returning to us. And I can actually copy this and to use for my mock response. So let me continue on to the code. So I clean the console, go to my login page, and try to log in. Happy developer2@gmail.com. Password is password 1. So I have successfully logged in. So now here, so the domain that the production domain for Google Firebase authentication is googleapis.com. So I search for the request. I have another request of this verify password. I can try this command out. Copy. And here is another successful response. So I can copy this and set up our mock responses. And the mock responses are here. One for sign up success, and another one for verify password. And I can do this for all the other requests that are used in my use case. So now let me show you how to apply LAIM onto the project. Okay. So can you remember what's the first letter? It's the letter L. And L, that's localhost. So firstly, I import in our test file, I import Swift localhost, and this is the GitHub page for this CocoaPod. And then I'll create an instance of Swift localhost for localhost server. In the setup, I will tell the server, I will initialize the server using a random port number. And then I'll tell the server to start listening. In the teardown, I'll tell the server to stop listening. After L, the next letter is the letter A, and that's API. I go to my networking class, and here I have a variable that will give me the request path, the full request path of the request I want to fire. So if I have the port value from the process info, which is will be given to me via by running XCUITest, I will use localhost assigned with the port number. Otherwise, I'll hit the production API. LA, the next letter is the letter I. And that's Info.plist. So we need to make some changes to Info.plist. Here, we go to App Transport Security Settings. And then we will need to add NS allow local networking for iOS 10 and above. But if you're still on iOS 9, you have to add localhost over here under exception domains. And lastly, after LAI is the letter M. And M stands for mock. So let's visit this test case. Here, I'll set up the route so that when the app hits this path 3 movie popular, we will get the localhost will return home popular. In the test case, let's look at the test case. For the first movie poster, we expect the movie name to be Fantastic Beasts: Crimes of Grindelwald. Second movie is Mission Impossible. Third movie is Bohemian Rhapsody. So let me go to home popular JSON file. And the first item is Fantastic Beasts: Crimes of Grindelwald. The second movie is Mission Impossible. And the third movie is Bohemian Rhapsody. So let me run this test to make sure that it's all working. Let me make this smaller. Okay. So you can see the 3 movies: Crimes, Mission Impossible, and Bohemian Rhapsody. Yep. And the test passed. So let me show you how to assert outgoing request. So in this login test over here, we basically set up a mocks. We're going to call home popular. And we are also going to hit verify password and get account info for logging in. In our test case, we're going to log in with the value, email field value, apple@gmail.com. And the password is password. And here is the path to assert. So we list now 3 movie popular, verify password, and get out account info as the ordered request that will be fired from the app to the localhost server. We can also describe it using curl commands. And take note, for the second item, we want to ensure that we are sending apple@gmail.com as the email and password as the password value. So let me clean up the simulator. Okay, so let me run all the tests, my tests in parallel to ensure that Swift localhost is working. Okay, the test pass, all the tests pass, cool. So you'll be asking, Kenneth, I'm actually using Firebase and I'm using the SDK. There's no way for me to change the URL to be redirected to the localhost. So how do you do it? So I have I have a special port that I use, which I've written. And this port allows me to redirect. It will actually take advantage of Apple's URL protocol framework. And whenever it sees this particular domain, which for now, in this example, is hitting Firebase authentication, we will instead redirect it to localhost. So if you want to play around with this repository, just go to this GitHub page. So now let's return back to our slides. Okay, some FAQ. Why can't we add start responses in our code? So some developers write UF tests by setting mock responses within the production code. So when a use case requires a network request is triggered, actual code execution will only reach the mock response and return the data back to the client. But this neglects other layers in the app, like the HTTP and the TCP layer. So such test does not correctly reflect how the app behaves in actual production. So if you're writing XCUITest in this way, this is not really recommended. So the localhost test, on the other hand, ensures that the code is that the code on all layers are executed for network requests to complete the use case. So what are the advantages of using Swift localhost over other localhost web server solutions? In this case, I'm referring to external solutions that are external to Xcode. So on one hand, we have Swift localhost, and the others we have like Vapor Swift, WireMock for Java, Typicode, Sinatra for Ruby. So the advantages with Swift localhost is easy installation, and you only need to use CocoaPods. And the only command you need to type in your terminal is pod install. You can use Swift to set up your localhost server, your mock response, your test code, as well as your production code. So it is just using one language across your whole entire project. And you can describe inline mock responses in the same scope as your test. You can also use the same runtime Xcode debugger as well. And the best of all you need to do is to hit Command U, because each test will take care of its own localhost, its own mock responses. So next question. So what if the APIs change? Won't our localhost-based test give us false positive? And yes, you are absolutely right. So let's go back to the test pyramid, where we have mobile contract test and mock response test. So I've already covered mock response test in this talk today, and I'll describe more about mobile contract test. So for mobile contract test, we are actually firing a request and assert an expected response from the server. This is generally headless and it's fast. And we want to execute it before we run any end-to-end test. And the best effective combination is to pair your mock response test with your mobile contract test. So how does localhost XCUITest fit in my development process? So let's visit the bookmarking use case. So suppose you are working with the backend API team and you want to draw up some API contract agreements. So in our app, we will navigate to the list field. We'll fetch a list of items using the list API. And when you hit that API with these parameters, you will get this JSON response that look like this. And that is your contract agreement number 1. Next, you tap on the item and navigates to the detail view. And the app fetches the detail using the detail API. You hit this API in a certain way, you get your response. And this becomes your contract agreement number 2. The user can bookmark the app, and the app fires another request to the bookmark API, and you get a JSON that looks like this, in this format, in this schema, and that is contract agreement number 3. And lastly, our assert statement to make sure that the bookmarking icon is correctly reflected. So when we collapse this, at the bottom we have the test cases, and at the top we have our contract agreements. And these contract agreements can be used as our mock responses. And the benefit of this approach, number 1, you can actually start development early. You can start your client development while your backend development is trying to get APIs properly built and running. And the second case, by using this approach, you will write features, iOS features, that will never ever fail. And why? Because the only time your feature will fail is when the contract agreement has changed. And you will know when they change because you have your contract test, which are trying to almost every day, every second, or every time a deployment, web deployment has been done, you run this test and hit the API servers and expect a certain response in that way. So by pairing these two sets of approaches together, you will, as iOS developers, you will write iOS features and you will never ever fail. When you pass this build to your QA, it will never fail your ticket. So now you can use this approach to build with confidence. So on to the closing. So localhost test is meant to complement but not replace end-to-end test. And XCUITest plus localhost can cover almost, if not all use cases. Considering having both mock response and mobile contract test. And I'd like to encourage all of you to start writing XCUITest. So these are the references I used in the talk. Do take note of the two GitHub pages, Network Interceptor and Swift Localhost. Yeah. So I actually gave a presentation in Singapore and wrote a blog post on using Network Interceptor to actually try to intercept SSL pin requests. So do take a look. And I've written a blog post on this talk because I presented this talk earlier in January in Singapore. So here's the blog post. It's on Medium, and here's the QR code. Okay, maybe just one point because I missed out. So it's important for each test to assign a random port number because different tests might want a different set of responses. So when we assign a different port number for each test, we can ensure that if we can run n number of execution simulators, we can run all the tests at the same time. So this definitely speeds up execution. Yeah. No other questions? Okay.
Okay.
Let's say that the backend breaks the contract and
Yes.
the API changes.
Yes.
So in one of the responses, there is a new property or something.
Yes.
This, okay, we understand that it's not detected from using this repo, but do you have any tools that could detect this kind of thing?
To discover such changes?
Yes.
Yeah, so this topic about testing, especially in mobile, is a very big topic. So today I only focused on localhost testing. So in my work, so actually when I joined the company, within a week or two, I introduced a mobile contract test where I actually write some simple HTTP requests to be fired using Ruby, so that both Android and iOS teams can contribute. So we look at what requests are being fired from the app. So every day or every time we deploy codes or the backend team deploy codes, we will fire the request. We want to make sure that the newly changed code will not break our apps. So in fact, I'm actually trying my best to actually change how we look at testing. So if the backend team were to change codes, deploy into production, and nobody else in the company caught these changes, and it goes into production, it breaks, whose fault it is? Traditionally, it's the backend team's fault. But I'm trying to push a different paradigm. So when that happens, actually the mobile team's fault. So instead, it's a good practice to actually write contracts that are tied to the actual implementation of the code. And then we tell the backend team, hey, you can deploy your changes as often as possible because I'm ready to actually catch any changes. At the same time, if your QA is actually trying to do some manual testing, you can easily run the contract test, where if the contract test fails, there's no point taking out the phone to test because something in the back end is not working well with the phone. Yeah.
Thank you.
Okay, thank you,
thank you.
Kenneth, for this amazing session ค่ะที่จะ